Talk to you about cuboids, something that some of you may have done before and some of you may not have done. I'm going to show you a couple of different ways that you can calculate this that will hopefully carry forward to the other 3D shapes you're going to do. Today there'll be some work on cuboids, and if this is something that you've done before and you find a little straightforward, then I will also post a couple of extension activities as well. So let's jump straight in with a cuboid. If you've forgotten what a cuboid looks like, or for some of you who just joined the school this year and you don't know what the word is in English, cuboid means a shape like that. So let's just dive straight into how a cuboid is made up. So I've just drawn a little cuboid for you here. We've got different parts of it, and I'll just label the different names. So first, the most important thing about a 3D shape is the front. So we've got a little face here. I've kind of highlighted it, very poorly coloured in yellow. The front of a shape, if we call a cross section, and this is for a prism. If you think about this shape, okay, if we turned it around, the front and the back of the shape are the same. Okay, the one that's facing us is the cross section. It's the same all the way through the shape. If I was to cut that shape in half, let's imagine I cut it like, cut down here like a knife, then it would open up and it would look the same. Like a loaf of bread, if you cut it in the middle, it looks the same. So when we think about 3D shapes, we think about them as two-dimensional shapes that are projected into 3 dimensions. That cross-section is a rectangle, but it's like we've projected it into 3D. And we draw it, when we draw it on paper, we draw it in what's called an isometric drawing. So I want you to think of this as a 4 by 3 centimeter rectangle projected into 3D for 3 centimeters. The other way we can think about it is if it was made up of blocks. If you imagine you had a tiny block, each block being 1 centimeter squared, 1 by 1 by 1, and you made it up like building like little bricks, like Legos, okay, it would look something like this. Look at that, here's one I made before. So as you can see, the front of the shape is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bricks. There's 12 bricks because obviously this brick here, for example, is, that's all just one brick there, that first one. How do we know there's 12? Well, 4 centimeters times 3 centimeters, the rectangle at the front is 12 centimeters squared. And that's what we've been revising with our area and perimeter last week. So the front or the cross section of that shape is 12 centimeters squared. It's also 12 little cubes to make it up. We can see that we've got 12 at the front. I'm just going to colour them for you. Let's imagine these are the yellow ones. Okay. But we can hopefully see that we've got layers. We've got a yellow layer there, then in the middle we've got like a green layer, and then at the back we've got like a blue layer. So we've got 3 sets of 12. So we've got 12 cubes times 3, we've got 36 cubes. So if I was to make this up using little small cubes, there's 12 at the front, which I've highlighted in yellow, and there's 3 sets because of the fact that we projected it 3 centimeters into 3 dimensions. So how does that help us when we want to calculate different things? Well, we know now that the shape is made up of 36 cubes. Literally, we can say that there are 36 cubes, centimeter cube, literally cubes, and there are 36 of them. How did we find that out? Well, we did the front, 4 times 3, and then we multiplied it by the 3 on the edge. Let's just have a little look at an example together. Ooh, jumping too far. So let's say I wanted to work out the volume of this cuboid. First thing you can do is say, well, let's think about that face at the front. It's 3 centimeters by 4 centimeters. So that face at the front is 12 centimeters squared. Remember, we call this the cross section. We can then see that this is projected 7 centimeters into 3D. So there are 7 sets of 12. Just like here, there were 3 sets of 12. Here now we have 7 sets of 12. So we take this 12 centimeters squared, that's from here, and then we say, well, we've got that 7 centimeters into 3 dimensions. 12 times 7 is 80. Ooh, that's a terrible layout, I'm not having that one. 84, and we say it's centimeters cubed. Why cubed? Because literally those cubes are those little building blocks, and you need 84 of them to make that shape. So volume of a shape of a cuboid is a nice easy one, because you just multiply the front by the projection, or the depth. So sometimes you'll hear this called the depth. Okay, so multiply the two at the front and the one at the side, or even easier, times them all together. But think of it as the front multiplied by the depth, because that will help us, well, not with cuboids, but when we do other shapes later in this unit. And as you can see, 3 times 4 times 7, 84 centimeters cubed. Don't forget your unit, centimeters cubed. Keep thinking about it as literally little cubes. What about if you have some other shapes that involved cuboids? Because that's really what we want us to get to in this, today. So in this one here, we can see that we've got two cuboids making a T. You've got like a cuboid at the bottom and a cuboid stacked on the top. And I'm going to show you two different ways that you can do this one. So, first way we can do it is we can do each individual cuboid. Let's think about this one as the top cuboid. Okay, so the top one, we could say, oh, well, I've got the front is 7 centimeters and 2 centimeters. It's 7 here and 2 here. And then it's projected 2 into 3D. So we do that one there. 7 times 2 times 2 is 28 centimeters cubed. 1, 2, 3 centimeters. That's why you've got a 3 there. We could then do the base, which is going to be this one here. B-A-S-E, base. And the base is going to be, the front is 5 times 2. And then it's projected 2 centimeters into 3D, which gives us 20 centimeters cubed. And then to work out the whole thing, 28 plus 20 is 48. So the whole thing is 48 centimeters cubed. So one way we can do it is we can work out each individual part and add them together. I'm just going to show you another way to think about this. Another way to think about it is, let's imagine you just worked out the area of the whole T. So I'll just highlight that in green for you. So I'm just going to do this bit here and this bit here, like the front of the shape. Okay. So the bit at the top is 7 centimeters and 2 centimeters. The bit at the bottom is 5 centimeters and 2 centimeters. We're going to add those together. Right, so the top is 14 centimeters squared and the base front is 10 centimeters squared. That's 14, that's 10, so 24 centimeters squared. We can then see that the whole shape, whether it's at the bottom here or the top here, is projected 2 centimeters into 3D. So we can think of, I have a 24 centimeter squared shape, projected 2 centimeters into 3D, and again you get the same answer, 48 centimeters cubed. So you can either think about it as the whole 2D shape at the front, going 2 centimeters into 3D, which is this bit here, or you can think of it as two parts that you add together. Doesn't matter, because you get the same answer both ways. And that is volume. The volume of a cuboid is the easiest of the 3D shapes. It's pretty straightforward. Multiply them all together. When you start to combine them, you can either think of it as like this one, where it's like the whole green T in 3D, or two parts. For this method here, sometimes when you get onto the more complex questions, this can be quite useful, especially when you start to look at questions with bits cut out, or bits chopped off, or added on, or stacked. So that's something to think about for those. So that's volume, but the other thing we can do is something called surface area. That's just an example of volume. Surface area is where, let's go back to our very first cuboid. Surface area is saying, if I added up the area of all of the different faces, so the top, the bottom, the left, the right, the front, the back, what would be the area of all the shapes together? If I was to wrap it in wrapping paper, how much wrapping paper would I need? So like this bit, and this bit, and this bit, and the left and the right and the top. Now, when we think about a rectangle, we need to think about what makes up a rectangle. And I've just done a little drawing here to show you. Anytime you get a box, which is the classic example of a cuboid, the top and the bottom are the same size, the front and the back are the same size, and the left and the right are the same size. And I've shown that on that little picture here. Now, what that means is we don't need, if we wanted to work out the area of all of the sides of a cuboid, we wouldn't need to do all of them. We just need to do one of them for each of these, the top, side, the front and the left, for example, and then double them. So, for example here, I could say, well, that's going to be the same as the top twice, that's going to be the same as the front twice, and that's going to be the same as the right twice. And if we added them all together, we'd get the total of all 6. This talks about a net, which I'm going to show you what that looks like in a minute. And it talks about 6 rectangles, because if you think about a box, there are 6 sides. The top, the bottom, the left, the right, the front, the back. So just keep this in mind, because we're going to have a go at some surface area in a second. So let's think about a cuboid like this. And you'll notice I've given you a cuboid which doesn't have any side lengths, because I want to think about it more theoretically. We've got X along here, that's like, so you're saying X is from here to here. We've got Y is from here to here. Oh, that's a terrible arrow. And you've got Z is from here to here. Okay. So let's say we wanted to do the front. I want to work out the area of this face at the front, this bit here. Well, the front is going to be X along and it's Z tall. So we'd say X times Z. So it can be XZ. We can also look at the top. Well, that's X along there, and it's diagonally, it's the Y. So it's XY. And finally, we've got the right-hand side here, which is Y times Z, YZ. So there's 3 parts which we've got. So what we can see at the moment is we've got XZ, XY, and YZ. So you've got to do 3 different combinations. But what we said a second ago is that we know we've got 2 of each. So we need to do 2 lots of the front, 2 lots of the top, and 2 lots of the side. And if we do that, it will give us the whole thing, because if we do 2 of them all, we know that we have 2 of each. Now what we've drawn here is something called a net. A net is like if you opened up the cuboid, what would it look like? So if you fold, you probably remember doing this in grade 6, where you fold it all up from a bit of paper and it makes a box. If you ever unpack a cardboard box, you can lay it flat like this. People do it for recycling, and it looks something like this. You can see that you've got different faces. We know that X times Z is the top. Sorry, no, it's not the top, that's rubbish, it's the front. Which means that this one is the back. We know that X times Y is going to be the top, which means this one is the bottom. Which means that this YZ is the left and the right. Or it could be right, left, left, right. So there's our 6 faces, and we can see that we get that formula there again. So what does that look like when we use numbers? Well, let's look at this one here. I'm going to show you 2 different ways you can do this. Okay, a longer way and a shorter way. The shorter way, you do need to understand a little concept, but I'll come to that in a second. So one way we can do it is we can say, okay, well, let's work out our three parts: the front, the top, and the side. Let's start with the front. The front is this bit here, obviously. It's 1 along the bottom, 5 along the side. 1 times 5, it's going to be 5 centimeters squared. Then let's think about the top, that long thin bit on the top. This side here is 1, and we've got a long 8. So we say it's going to be 1 times 8, and that's 8 centimeters squared. Finally, the side is like quite a long tall bit here by this one here. So it's 5 by 8. 5 is that bit, 8 is that bit. And that's 40. And if we added those all together, 40 plus 8 plus 5 would be 53. But we know that we need 2 of each because we've got a top and a bottom, a left and a right, a front and a back. So we'd say 2 lots of the 53 that I have, and that would give you 106 centimeters squared. That is all of the sides added together, the area. How much space it takes to cover them. Now, like I said, there is another way that you can do it for cuboids. Okay, let's go back to this shape here. Think about this length along here. Okay, that length there is the same as this here. It's the perimeter of the front. So I'm just going to highlight it for you so you can see it. We could work out the perimeter of the front. And hopefully you've been doing your revision, which we did last week, of perimeter of rectangles. We say you've got 5, obviously here, and a 1 on the top. So it's going to be 2 lots of the 5 and the 1. So that's 12 centimeters. So that yellow perimeter is 12 centimeters long. We know, as from before, that we've talked about projecting into 3D. So let's take that 12, and if you think about it, the gap between, we've also got this one at the back, and there's 8 centimeters between them. So if we multiply that by the 8 centimeters there, we get 86 centimeters squared. We're going to use that, we're not finished yet. That 86 centimeters squared is the middle faces. That's this one, the bottom, and the sides. But it doesn't include the front and the back, which we still need to do. So we know the front and the back. Well, from before we know that we have 5 by 1. It's 5 centimeters squared, but we know that we have 2 of them. So 2 times 5 is 10 centimeters squared. Something's gone wrong here. That's not 86, that's 96. Just notice that. That's embarrassing. That's okay. So we've now got this 10 here. And if we put those together, 96 plus 10 is 106 centimeters squared, and that is our answer. So we can do the perimeter of the front times the length plus 2 at the front. And I'll write that formula down for you. You can do perimeter of front times the depth plus 2 lots of the front. And that is another way that you can do the surface area of 3D shapes. So, have a go at the questions I've set you today. Remember, there's 2 methods for each thing. Just went to a screensaver, that's annoying. And see how this goes.